Stealth was supposed to make fighter jets untouchable. But what if the real threat isn't being seen, it's being studied? Modern radars no longer hunt targets, they adapt to them. And in that silent chess game between stealth and sensors, the aircraft that learns faster may win before the first shot is fired. Stealth is often misunderstood as invisibility. In reality, it means low observability, an aircraft designed to be harder to detect, not impossible to see. That advantage comes from two things: shape and materials. Radar waves are deflected away, and whatever energy comes back is weakened. The radar doesn't see nothing, it sees less. Here's the paradox. Stealth designs are mostly static. Modern radars are becoming adaptive. AESA radars no longer just send a signal and wait. They shift frequencies, change beam patterns, and analyze how targets react. Radar is no longer just detecting, it's learning. This breaks a dangerous assumption. Stealth makes radar irrelevant. It doesn't. Recent defense discussions show that while stealth isn't obsolete, it's no longer untouchable. Systems built decades ago are now being tested by sensors that evolve in real time. Most people assume only jets like the F-35 Lightning II dominate this space. But another approach exists. Instead of hiding better, scan smarter. That's where Gripen comes in. Stealth relies on unpredictability. But if a radar becomes even more unpredictable, the balance starts to shift. In the next section, we'll see exactly how Gripen's adaptive radar exploits that opening without ever claiming to defeat stealth.
At this point, we need to clear some fog, because AESA radar is often mentioned but rarely explained. AESA stands for Active Electronically Scanned Array. Unlike older PESA radars, which rely on a single powerful transmitter, AESA uses hundreds to thousands of tiny transmit-receive modules, all working independently. That alone changes everything. Older radars shout. AESA radars whisper, shift, and move. Each module can send its own signal, at its own timing, and even at its own frequency. No mechanical movement, no delay, just pure electronic control at near-instant speed. Now here's where Gripen pushes things further. On the Saab Gripen E, the Raven ES-05 isn't just AESA, it's adaptive. That means the radar doesn't stick to a fixed frequency band. It can hop across a wide spectrum in real time, changing its behavior every fraction of a second. Why does that matter? Because stealth aircraft and electronic warfare systems depend on prediction. They analyze radar behavior, identify patterns, and then either absorb, deflect, or jam those specific frequencies. Gripen breaks that logic. The moment the radar senses interference, or even the possibility of interference, it shifts. New frequency, new timing, new angle. The window to react becomes so small that countermeasures struggle to keep up. Here's a simple analogy that actually works. Think of stealth like camouflage clothing. Now imagine the environment changing colors every second. That's what Gripen's radar does. It's a chameleon, but not hiding, hunting. And this is where another assumption collapses. If you know the radar, you can defeat the radar. Only if the radar stays the same.
Gripen's AESA doesn't just change frequencies, it changes how it looks. Traditional radars scan in predictable sweeps. Gripen's radar constantly reshapes its scan patterns. Narrow beams become wide beams snap tight, angles shift, revisit times change. The radar stops behaving like a lighthouse and starts acting like a searching mind. For stealth aircraft, this is a problem. Stealth relies on minimizing radar returns from expected angles. But when the radar keeps changing where and how it looks, those carefully engineered blind spots don't stay blind for long. The radar isn't forcing a detection, it's accumulating clues, pass after pass. This leads directly into ECCM, electronic countermeasures. Modern stealth aircraft don't just hide, they fight back electronically. They jam, deceive, inject false targets, or try to overwhelm sensors with noise. Gripen's AESA is built to expect this. Instead of being confused by interference, it treats jamming itself as data. If something tries to blind the radar changes behavior. If something tries to deceive it, the radar cross-checks from another angle. If something gets noisy, the radar goes quieter and sharper. This is ECCM at work. not brute force resistance, but adaptive resistance. On the Saab Gripen E, this means the radar can maintain a persistent track even under heavy electronic attack. Not a perfect lock, not a clean picture, but enough information, refreshed constantly, to keep the target from slipping away. And here's the tactical shift that matters. When a stealth aircraft is forced to jam, maneuver, and constantly adapt, it stops being a ghost and starts leaving fingerprints. The hunter becomes cautious, sometimes reactive. My personal assessment, Gripen doesn't need to see stealth clearly. It just needs to see it longer than stealth expects. In modern air combat, persistence beats perfection. Next, we'll connect all of this to the bigger picture, what this means for real-world air battles, force balance, and why adaptability may matter more than raw stealth in the decade ahead.
By now, one thing should be clear. Gripen's radar doesn't work alone. It was never meant to. On the Saab Gripen E, the AESA radar is just one instrument in a much larger electronic warfare orchestra. The real power comes from integration, tight, fast, and deliberate. Here's the key shift in thinking. Instead of relying on radar to find everything, Gripen leans heavily on passive EW sensors first. These sensors don't emit anything, they just listen, picking up faint electromagnetic leaks, data links, radar side lobes, electronic whispers that stealth aircraft still can't fully suppress. Stealth can reduce reflections, it cannot stop emissions. Once Gripen's EW suite detects something suspicious, it cues the AESA radar. Not a wide, obvious scan, but a focused, adaptive sweep, tuned in frequency, angle, and timing to that specific anomaly. The radar isn't searching blindly anymore, it's following a lead. This synergy matters because it flips the engagement logic. Instead of radar finds target, EW reacts, Gripen operates as EW senses first, radar confirms surgically. The result is a layered picture of the battle space. Radar returns, passive detections, electronic behavior, all fused into a single tactical view. Even if no single sensor has a perfect track, together they build situational awareness that's hard to break. My personal view, this is where low observability starts to crack. Not because stealth fails, but because no aircraft is stealthy across every sensor, every band, all the time. Integration exploits those moments. Gripen doesn't chase invisibility. It listens, correlates, and then looks, only when it matters. Next, we'll take this system out of theory and into reality, what these capabilities mean in real combat scenarios, and why agility may outweigh raw stealth in future air wars.
Thanks for watching viperJet Wings. Gripen's adaptive AESA doesn't defeat stealth, but it redefines the rules that made stealth dominant in the first place. For decades, air combat logic was simple: hide better, survive longer. Gripen challenges that by proving something uncomfortable. Adaptability can rival invisibility. Stealth aircraft still matter, hugely, but they no longer operate in a vacuum where radar is dumb and predictable. Systems like those on the Saab Gripen E force stealth to constantly adjust, react, and expose slivers of information. Air combat shifts from a binary seen versus unseen problem to a continuous contest of learning speed. Looking forward, this reshapes aircraft design philosophy. Future fighters won't rely on a single silver bullet, neither pure stealth nor raw sensor power. Instead, we're heading into an arms race defined by sensor fusion, electronic warfare, AI-driven adaptation, and resilience under jamming. Stealth will evolve, counter-stealth will evolve faster, and neither side gets to stand still. This has serious strategic implications. Gripen shows that air dominance doesn't have to be astronomically expensive to be credible. A cost-effective, networked, electronically sophisticated platform can survive and even thrive in airspace crowded with stealth aircraft, drones, and electronic attack systems. My personal conclusion is blunt. The future of air combat belongs less to the aircraft that hides best and more to the one that thinks fastest under pressure. Gripen isn't betting against stealth, it's betting on evolution, and in modern warfare, evolution usually wins.